Good morning to one and all. This video lecture presented from Government College of Engineering, Dharmaburi. This video lecture is for subject Power Plant Engineering, in which we are going to talk about Unit 5, Energy, Economic and Environmental Issues of Power Plant. The topics covered under this unit is power tariff types, load distribution parameters, load curve, comparison of site selection criteria, relative merits and demerits, capital and operating cost of different power plant, population control technologies including waste disposal, option for coal and nuclear power plant. First of all, we are going to talk about load, in which connected load, it is the sum of rating in kilowatts of each equipment installed by the consumer. If the consumer connected 4 tube lights of each 40 watts and 2 fans of each 60 watts, then connected load can be calculated by 4. We are using 4 tube lights, so 4 into tube lights in watts 40, so 4 into 40 plus 2 fan into 60 watts, so totally connected load will be 280 watts. Next, maximum load, it is the maximum possible load which a customer use at any time. Next, demand factor is nothing but ratio between maximum load to connected load, so this demand factor is always less than 1. For an example, maximum demand 85 megawatt and then connected load is 100 megawatt, so demand factor is calculated by maximum load divided by connected load, so 85 divided by 100, so the answer will be 0.85. Next one is load factor. Load factor is nothing but ratio between average load to peak load, so average load is nothing but energy consumed in a given period of time to peak load into hours of operation in that given period. It is always less than 1. It plays key role in determining the power unit generation cost. Next, diversity factor, it is the ratio between sum of individual maximum demand to maximum demand of the whole. For an example, we are having 4 customers, so customer 1 connected load usage is 250 kVA and customer 2 usage 200 kVA, customer 3 150 kVA and customer 4 400 kVA, and the demand factor of customer 1 is 90%, customer 2 is 80%, customer 3 75%, and customer 4 85%, and they have given diversity factor of 1.5. so sum of individual demand, so we have to make sum of all kVAs, so 250 plus 160 plus 112.5 plus 340, so overall it will be 837.5 kVA. so demand factor of feeder circuit is equal to 837.5 divided by 1.5, so the answer will be 558 kVA. If the diversity factor 1 means it requires 850 kVA transformer. Next, plant capacity factor, so the ratio between energy produced in a given period to capacity of the plant into total number of hours in given period. A power station is so designed that it has some reserve capacity for meeting the increased load demand in future. Therefore, the installed capacity of the plant is always greater than the maximum demand of the plant. So reserve capacity is nothing but difference between plant capacity and maximum demand. Next one is plant use factor, the ratio between energy produced in a given period to capacity of the plant into actual number of hours the plant in operation. The plant having installed capacity of 20 megawatt produce annual output of 7.8 into 10 to the power 6 kVh and remains in operation for 2190 hours in a year. Then plant use capacity, energy produced in a given period is given as 7.8 into 10 to the power 6 kilowatt hour to capacity of the plant. Here they have given us 20 megawatt, and then actual number of hours the plant in operation is 2190 hours. So the answer will be 0.178. Next, utilization factor, the ratio between maximum demand on the power plant to capacity of the plant. Next, load curve and load duration curve. First of all, load curve, a graphical record showing the power demand for every instant during a certain time interval. So in this graph we can able to see time on x-axis and load on y-axis. So here for a day it will be 24 hours. So from morning 6 a.m. to 6 a.m. next day 6 a.m. So in between that duration, what will be the load? We are mentioned that one in y-axis. So between 6 a.m. to 8 a.m. so the load will be 18 kilowatt, and from between 8 a.m. to 2 p.m. it will be 35 kilowatt. Like that for 24 hours they have mentioned in the load curve. Then next one is load duration curve. It represents rearrangement of all the load elements of chronological load curve in order of descending magnitude. So here in this graph, so in the load curve graph, so between 8 a.m. to 2 p.m. so the load will be maximum at the range of 35 kilowatt. So we have to rearrange this in descending order. So that is nothing but from maximum load to minimum load. So for an 8 a.m. to 2 p.m. it will be 6 hours. For that 6 hours here in load duration curve we have to mention in first, and then so the load will be in descending order: 35 kilowatt, 30 kilowatt, 24 kilowatt, 18 kilowatt, and then 3 kilowatt. Next one is significance of load curve. It shows the variation of load on the power station during different hours of the day. The area under the daily load curve gives the number of units generated in the day. The highest point on the daily load curve represents the maximum demand on the station on the day. It helps in selecting the size and the number of generating units. It helps in preparing the operation schedule of the station. The area under the curve divided by the total number of hours gives the average load. So how we can calculate the average load? Means the ratio between total energy to time period. So the time period is calculated for per n day. So per day we are having 24 hours. Likewise we can able to calculate the next one is power factor. So the power factor plays an major role in the plant economics. The low power factor increase the load current, which increase the losses in the system. Thus the regulation becomes poor. For improving the power factor correction equipment is installed at the generating station. Thus the cost of the generation increases. Without these power factor correction equipments, the home appliance what we are using in our home, it will not work properly. So that's why we are using this power factor correction equipments. Next topic is site selection for power plants. So for site selection we need to follow some of the important factors like availability of fuel, availability of water, cost of land, nature of land, transportation, waste disposal, size of the plant, nature of land, load center, public safety, future extension, availability of labor. First of all, availability of fuel. So in steam power plant we are using coal as the fuel. So it should be located near to the coal field. So for a diesel power plant we have to shoot at the plant nearer the fuel station. For hydroelectric power plant water is very important. So we have to propose the site near to the reservoir dam like that. Then gas power plant. So we are using gas is the fuel. So we have to plan the site near to the gas power station. Then nuclear power station, here we are using uranium is the fuel used in nuclear power plant, and it should be shooted near to that. Next, availability of water. So water is a working fluid and coolant for cooling tower also. So therefore it should be located nearer to river, reservoir or sea. Water is the coolant for diesel power plant also. So water is one of the important factor for all the power plants. Next, cost of land. So the cost of land should be reasonable. Next, nature of land. Land should have high bearing capacity to withstand dead load. Mostly coastal area is suitable for power plants. Next, transportation. Approach of railways and road transport is necessary for land transport of coal and heavy machineries. Waste disposal. So for steam power plant and nuclear power plant we need some special method for waste disposal. Remaining diesel, hydroelectric power plant, gas power plant. So here waste disposal is not too much. Next is size of the plant. Large size is economical for steam power plant, hydroelectric, gas power plant and nuclear power plant. So the plant size should be large enough. Next, nature of land. The land should be cheap and rocky. Next, load center. The site for the power plant should be near to the load area. The site for the diesel power plant should be nearer to the load center, and transmission losses should be minimized when peak loads. The site for the power plant should be nearer to the land area to reduce the transmission losses. The site for the gas power plant should be nearer to the load center, and transmission losses should be minimized when peak loads. The site for the power plant should be nearer to the load area if possible. Next, public safety. So for steam power plant it should be located far away from the towns to avoid the nuisance of fly ash and smoke. For nuclear power plant it should be located far away from the populated area to save them from hazardous. For a gas power plant it should be located far away from the residential area and business to avoid the heavy noise and smoke. Next, future extension. So for steam power plant the site should allow future extension. For hydroelectric power plant it is not applicable. For all other all other power plants future extension should be allowed. And then last parameter is availability of labor. So labor should be available nearby site for all these types of power plant. Without labor we can't able to do work. So our availability of labor is one of the important parameter. So these are the things under site selection for power plants.